Hello viewers, welcome to our channel Career Prep. In this video, we'll learn about the concept and formulae on the topic compound interest. This topic is an important topic for many competitive examinations like SSC, UPSC, railways, banking, etc. Compound interest questions are asked every year in bank and SSC exams. These questions are also asked under data interpretation and data sufficiency. So, it makes sense to understand the concept well. These questions are the ones where marks can be scored easily if practiced well. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. Let's understand the meaning of the word interest and the types of interest. When a person lends money to a borrower, the borrower usually has to pay an extra amount of money to the lender in addition to the borrowed money. This extra money is what is called the interest. Interest can be either simple or compound. Simple interest is based on the original principal amount of a loan or the deposit. Compound interest, on the other hand, is based on the principal amount and the interest that accumulates on it in every period. Thus, compound interest is based on the amount of the previous period. We'll learn about compound interest in this video. Let's understand in detail what is compound interest. Compound interest is the interest calculated on the principal and the interest earned previously. That is, compound interest is equal to interest on principal plus interest on existing interest. Now we know that principal plus interest is nothing but amount. Thus, the interest charged every year on the amount of the previous year is called compound interest. Compound interest is denoted by CI. Money is said to be lent at compound interest when, at the end of a fixed period, the interest that has become due is not paid to the lender, but it is added to the sum lent, and the amount thus obtained becomes the principal for the next period. The process is repeated until the amount for the last period has been found. The difference between the original principal and the final amount is the compound interest. Let's now understand the concept of compound interest with the help of an example. While calculating compound interest, the interest so far accumulated is added to the principal and the resulting amount becomes the new principal for the next interval. Let's look at an example. Let's find the compound interest on rupees 1000 for 2 years at 10% per annum. So here principal for the first year is rupees 1000. Interest for the first year is 10% of 1000, which is rupees 100. Now the amount at the end of the first year is equal to principal plus interest, which is rupees 1000 plus rupees 100. So the amount at the end of the first year is rupees 1100. Now this amount at the end of the first year is carried forward to the next year as the principal for the second year. So the principal for the second year is rupees 1100. Interest for the second year is 10% of 1100, which is rupees 110. Now the amount at the end of the second year is equal to the principal for the second year plus the interest for the second year, which is rupees 1100 plus rupees 110. So the amount at the end of the second year is rupees 1210. Now compound interest is nothing but the final amount minus the original principal. So the compound interest on rupees 1000 for 2 years at 10% per annum is rupees 1210 minus rupees 1000, which is rupees 210. So the compound interest is rupees 210 here. Now you can observe here that for the first year, the simple interest and the compound interest, if compounded annually, is the same. So for the first year, the simple interest and compound interest is the same. In compound interest, for every changing year, the principal changes, and accordingly, the interest also changes every year. Now, since principal increases every year, compound interest also increases every year. Thus, compound interest is always more than the simple interest. The knowledge of conversion period is very essential to solve problems on compound interest. So, let's understand the concept of conversion period in detail. Compound interest is calculated at regular intervals like annually or yearly, semi-annually or half-yearly, quarterly, monthly, etc. The period at the end of which the interest is compounded is called the conversion period. In the case of the interest being compounded yearly, the number of conversions is 1. That is, the interest is compounded and added to the principal at the end of the year. So the number of conversion is 1 when the interest is compounded yearly. Interest may also be compounded and added to the principal half yearly, that is twice a year. In this case, the number of conversions per year is 2. Now, when interest is compounded half yearly, it means that the interest is added to the principal at the end of each half year. Now, we know that in a year there are 2 half years. So, the number of conversions per year is 2. If interest is compounded every 3 months or quarterly, the number of conversions in a year is 4. That is, when interest is compounded quarterly, it means that the interest is added to the principal at the end of each quarter. Now we know that there are 12 months in a year, which means there are 4 quarters in a year, and each quarter is equal to 3 months. Now, since there are 4 quarters in a year, the number of conversions in a year is 4 when interest is compounded quarterly. If the interest is compounded every month, the number of conversions in a year is 12. That is, if interest is compounded monthly, it means that interest is added to the principal at the end of every month. Now, since there are 12 months in a year, it means that the number of conversions in a year is 12 when interest is compounded monthly. Hope you have understood the concept of conversion period. Now, you have to note a few points regarding conversion period. Unless the problem specifies, it is assumed that the interest is compounded yearly. If compound is reckoned quarterly or half yearly, then the compound interest rate for 1 year is called the effective annual rate. Let's understand the definition of a few important terms used in compound interest. Principal. The money borrowed or lent out for a certain period is called the principal or the sum. Principal is denoted by the letter P. Interest. Interest is the extra money that the borrower pays for using the lender's money. Amount. The principal and the interest together is called the amount. Amount is denoted by the letter A. Rate percent per annum. The interest that the borrower has to pay for every 100 rupees borrowed each year is known as the rate percent per annum. The rate of interest is denoted by the letter R. Time. The time for which the borrowed money has been used is called the time. Time is denoted by the letter N. Simple interest. Simple interest is payable on principal. Compound interest. Compound interest is payable on the amount. Here are a few formulae which will help you to solve compound interest problems. Let principal be P, rate of interest be R percent per annum and time be N years. Now we know that compound interest is equal to A minus P, that is final amount minus original principal. So if we know the value of the final amount and the original principal, we can easily calculate the compound interest. Now there are a few formulae to find out the amount for various compounded period. So here are a few amount formulae. Now when interest is compounded annually, amount can be calculated using the formula A is equal to P multiplied by 1 plus R by 100 raised to the power N. When interest is compounded half yearly. Now we know that in 1 year there are 2 half years. So to find the rate of interest for each half year, divide the annual rate of interest by 2. Also to find the number of half years, multiply the time with 2. So when interest is compounded half yearly, the formula to find the amount is A is equal to P multiplied by 1 plus R by 2 divided by 100 raised to the power 2n. When interest is compounded quarterly. Now we know that in 1 year there are 4 quarters. So to find the rate of interest for each quarter, divide the annual rate of interest by 4. Also to find the number of quarters, multiply the time with 4. So when interest is compounded quarterly, the formula to find amount is A is equal to P multiplied by 1 plus R by 4 divided by 100 raised to the power 4n. When interest is compounded monthly. Now we know that in 1 year there are 12 months. So to find the rate of interest for each month, divide the annual rate of interest with 12. Also to find the number of months, multiply the time with 12. So when interest is compounded monthly, the formula to find the amount is A is equal to P multiplied by 1 plus R by 12 divided by 100 raised to the power 12n. When interest is compounded annually but time is in fraction, for example 6 3 by 4, here time is nf, where n is the whole number and f is the fraction. So here n is 6 and f is 3 by 4. So when interest is compounded annually but time is in fraction, the formula to find the amount is A is equal to P multiplied by 1 plus R by 100 raised to the power n multiplied by 1 plus F multiplied by R divided by 100. Now in this particular example where time is 6 3 by 4, The formula to find the amount would be A is equal to P multiplied by 1 plus R by 100 raised to the power 6 multiplied by 1 plus 3 by 4 multiplied by R divided by 100. When rates are different for different years, say R1% for the first year, R2% for the second year, R3% for the third year, and so on. The formula to find the amount is A is equal to P multiplied by 1 plus R1 by 100 multiplied by 1 plus R2 by 100 multiplied by 1 plus R3 by 100 and so on. So once amount is found using the amount formula and principal is known, compound interest can be easily calculated using the formula CI is equal to A minus P. Memorize and remember all these formulae which will help you to solve compound interest problems easily. Here are a few more formulae on compound interest. Let's suppose you need to know how much to invest now to get rupees 10 lakhs in 10 years at 8% interest rate. Here, rupees 10 lakhs is the future value FV, 10 years is the time N, and 8% is the rate of interest R. How much you need to invest is the present value PV. So to calculate the present value, use the formula PV is equal to FV divided by 1 plus R by 100 raised to the power N. So in a few problems in compound interest, the terms future value and present value might be used. There is no need to get into any confusion regarding these terms. Just remember that present value is nothing but the original principal and future value is nothing but the final amount. Sometimes in a few problems in compound interest, the difference between compound interest and simple interest is given for either 2 years or 3 years. So let's look at those formulae. Now if difference between compound interest and simple interest is given for 2 years, use the formula CI minus SI is equal to P multiplied by R by 100 raised to the power 2. Now Ci minus Si is also equal to Si multiplied by R divided by 200. So in the problem, if you are asked to find the principal and the difference between the compound interest and simple interest is given for 2 years, then use the formula Ci minus Si is equal to P multiplied by R by 100 raised to the power 2. If in the problem you are asked to find the simple interest and the difference between compound interest and simple interest is given for 2 years, then use the formula Ci minus Si is equal to Si multiplied by R divided by 200. If the difference between compound interest and simple interest is given for 3 years, then use the formula Ci minus Si is equal to P multiplied by R by 100 raised to the power 2 multiplied by R by 100 plus 3. The next formula in compound interest is the rule of 72. This rule is used to find either the time or the rate of interest required for a sum of money to double itself. To find the time required for a sum of money to double itself at a given rate of interest, the formula is time is equal to 72 divided by rate of interest. And to find the rate of interest at which a sum of money doubles itself in a given time, the formula is rate of interest is equal to 72 divided by time. The next formula in compound interest is used to find the annual installment. If a sum P is borrowed at R% annual compound interest, which is to be paid in N equal annual installments, including interest, then for N is equal to 2, each annual installment is equal to P divided by 100 by 100 plus R plus 100 by 100 plus R the whole squared. For N is equal to 3, each annual installment is equal to P divided by 100 by 100 plus R plus 100 by 100 plus R the whole squared plus 100 by 100 plus R the whole cubed. Let's now look at a few applications of compound interest. Compound interest finds its usage in most of the transactions in the banking and finance sectors and other areas. Some of its other applications are in growth and depreciation. Growth is nothing but the relative increase in quantity. Growth per unit of time is called the rate of growth. Depreciation is nothing but the relative decrease in the value of a machine or any other article over a period of time. Depreciation per unit time is called the rate of depreciation. The value at any time is called the depreciated value. Here are a few formulae which will help you to solve problems on the topic growth. The formulae for calculating the growth of population, height of a tree, number of bacteria, etc. are exactly similar to the formulae used for computing the compound interest and amount. Let's assume that P is the population at the beginning of a certain year. That is, P is the initial population. Now, if the constant rate of growth is R% per annum and you have to find the population after n years, then the formula is population after n years is equal to P multiplied by 1 plus R by 100 raised to the power n. Now, when you observe this formula, you'll see that this is exactly similar to finding the amount after n years. The net increase in population during n years is equal to population after n years minus initial population. When you look at this equation, you'll see that this is exactly similar to finding the compound interest after n years, which is compound interest is equal to the final amount minus the initial principal. Let's look at a few more formulae in the topic growth. If the rate of growth is R1% per annum during the first year and R2% per annum during the second year and so on for n years, then the population after n years is equal to P multiplied by 1 plus R1 by 100 multiplied by 1 plus R2 by 100 and so on. Now, when you observe this formula, you'll see that it is similar to finding the amount after n years when rate percent is not the same for every year. If the constant rate of decrease is R% per annum and you have to find the population after n years, then the formula to be used is population after n years is equal to P multiplied by 1 minus R by 100 raised to the power n. Now this formula is obtained by simply putting minus R in place of R in the basic formula. The negative sign is used because there is a decrease in rate percent. Let's now look at a few formulae which will help us to solve problems on the topic depreciation. Let V be the value of a machine at a certain time. That is, let V be the original or the initial value. If the constant rate of depreciation is R% per annum, then to find the value of a machine after n years, use the formula value of the machine after n years is equal to V multiplied by 1 minus R by 100 raised to the power n. If the rate of depreciation is R1% per annum during the first year and R2% per annum during the second year and so on for n years, then if you have to find the value after n years, then the formula to be used is value after n years is equal to V multiplied by 1 minus R1 by 100 multiplied by 1 minus R2 by 100 and so on. Let's now look at the different types of questions on compound interest asked in competitive exams. The first type is to find the amount. The second type is to find the compound interest. The third type is to find the principal. The fourth type is to find the rate of interest. The fifth type is to find the time. The sixth type is to find the rate of interest or time or amount when sum multiplies. The seventh type is to find the rate of interest or sum when amount for different years is given. The eighth type is questions involving both simple interest and compound interest, where either the simple interest or compound interest has to be found out. The ninth type is questions where either the difference in compound interest and simple interest is given, or the difference in compound interest and simple interest has to be found out. The 10th type is questions based on installments. The 11th type is questions based on growth and depreciation. We'll solve a few problems on each of these types in the coming videos. Viewers, please go through this video till you have understood the concept and have memorized all the formulae. Solving compound interest questions using the formula is the traditional method. But there are other methods for solving compound interest questions without using the formulae. To learn more about these methods, please do watch our video Methods to Calculate Compound Interest. If you have liked this video, please like, subscribe and share this video. Thank you.